maybe jump to OnScale. Like, what is OnScale in the first place? How does it facilitate work for engineers?
Yeah, sure. So, part of being an engineer, I asked myself, why don't we have cloud simulation? Why can't I go create a massive AWS cluster and run a bunch of simulations in parallel rather than running them serially in on a desktop computer? Because as you know, engineers never want to run just one simulation of a design. You want to look at lots of different permutations of that design. You want to do design space optimization. You want to do multidisciplinary optimization. You want to look at multiphysics to perfect a design before you go spend a lot of money making something. That whole process is what we now call digital prototyping versus physical prototyping. And if you include digital prototyping in your R&D process, you can massively reduce risk, cost, and time to market. That was our thesis for OnScale. And the other thesis was, now that real cloud high performance computing, cloud supercomputers are available, now is the time to create a true cloud simulation platform. Cloud HPC wasn't a thing, pre 2015. You couldn't go get a 96 core bare metal machine from AWS, and you couldn't combine a bunch of 96 core bare metal machines together on a Kubernetes cluster to make a supercomputer in 2015 or 2016. But now we can do that. So you asked about what OnScale is. Fundamentally, OnScale is a cloud simulation platform that has a cloud supercomputing layer at its hardware layer. It has a solver layer. We've built our own solvers, and we also use third-party solvers, and very soon we'll be using Ansys solvers on the OnScale platform. And we can sequence these solvers together. So we can run a mechanical simulation, and then a fluid simulation, and then EM simulation, because we've containerized each of these solvers, and that allows us to use them when and where they're needed in the simulation workflow. So that's a solver layer. And then the top layer that you see as an engineer is you see the UI. You see a very nice, easy to understand 3D point and click simulation environment. And if you want to go a layer deeper, you can open up what we call Sim API, which is an API. It's a Python-based API that drives simulations and drives simulation sequences. And our philosophy is that you, as the engineer, you shouldn't have to worry about what type of hardware you're running on. All you care about is getting great data from your digital prototype or your simulation study. And I like to say that you could give an engineer a crystal ball, and if it gave him good engineering data, he would use it and he wouldn't care how it worked. So that's the philosophy behind OnScale. We don't tell the engineer what type of instances we're running on AWS. Instead, we look at how the engineer has set up the simulation, and then our AI that we've trained on millions of simulations will go and select the appropriate hardware to run that simulation in the most cost-effective and time-effective manner. And all we do is we charge the engineer for the compute power, the core hours associated with running that simulation. And we tell the engineer up front how many core hours that simulation study will cost him before he hits run. So that's what I mean by a true engineering simulation platform.
I really love that, Ian. Also, the aspect of like using SimAI, using artificial intelligence to actually augment or enhance engineering workflows instead of saying we disrupt engineering workflows and like substitute engineers in the first place. So I really love that aspect.
Yeah.
And we'll come back to artificial intelligence in a few minutes.